Hello everyone, welcome in a new video. In this video, we are going to understand about deadlock. So, what is basically a deadlock? Deadlock, when two or more processes are waiting for such an event which will never occur, then we can say that deadlock is occur. Okay, so when the two or more when two or more processes are waiting for such an event which is never going to occur, then we can say that deadlock is there. To understand deadlock in detailed way, so we need to understand the representation. When we see the representation of a processes and some other stuff, then we understand deadlock in a very efficient way. Okay, so we need to understand about RAG, which is resource allocation graph. Okay, we need to understand about resource allocation graph, that how the resource is basically attached to the process and how process is request for the resource. So when we understand about the diagram, then we can easily understand that when will the deadlock occur and what are the criteria that basically uh, shows that deadlock is occurring in our program. Okay, so resource allocation graph basically, with the help of the some circles, arrows, we can able to identify that which process request for which resource and which resources assigned to which process. So there are two main thing in this: nodes, or you can say vertices, which is basically two things which represent this. First one is process, and process is represented by the circle. Process is represented by the circle. Let's say the process is P1, so we represent process in this way. And the second is resource, that what resource is basically assigned to which process. So resource is represented by the rectangle. Resource is represented by rectangle. And this resource, let's say R1, so R1 is represented by the rectangle. What happen if there are more than one resource? So for this so many resource instance, not a resource. If I say there are two resource R1 and R2, means this is what R1 resource and this is what R2 resource. But when I say about resource instance, it means that this R1 resource is consist of three resources. So let's say I say R1 have three instance of resource. So means R1 have three space for the process, means three process can use R1 resource at a time, at a simultaneously basically. Okay, so we represent this in that dot way. If I say three instance, this is what three instance, then I say three dot in a rectangle. Okay, if I say two instance of R2, so two dot of R2. So this is how the resource is basically represented. Okay, now we understand about the nodes, and the second important thing, which is the edges. Edges is also categorized in two ways. First one is allocation. Allocation means from resource instance to process instance. Means let's say that R2 is assigned to P1. P1 is basically having R2. So how we represent this thing? With the help of edges, with the help of arrow. So when we say allocation, means from resource instance, to process. Okay, now the second thing is request. Let's say that P1 is a process which want resource R5. P1 is a process which want resource R5. So means P1 request R5 to get an access. So this is what a request is. And request means from process to resource, means from process to resource, from process to resource. So this is what the basic theory about resource allocation graph. Let's understand this thing with the help of these diagrams. Okay, so let's say that this is what P1 process, P2 process, and P3 process, and we have four resources as well, R1, R2, R3, and R4. Okay, we have three process and four resources. When I say that P1 have R1 resource, P1 is having R1 resource means the arrow, the edge is basically goes from R1 to P1. This represents that P1 is having R1 resource. This means allocation. This means what? Allocation. And when I do, let's say here is a process P4, and when I do like arrow this way, means from process to a resource. From process to a resource, it means P4 request for R2 resources. P4 basically request for R2 resource. Okay. Similar way, let's say P1 is having R3 resource as well. So we represent it like this. Let's say P2 wants R3 resource. So it represent like this. Oh, when I say that P2 want R3 resource, it means R3 is not available at a point. And right now, basically, R3 is not available right now because R3 is basically allocated to P1. That's why P2 request R3. Okay. And similar way, P2 is having a 4 resource, P3 want a 4 resource. So this is what the RAG, resource allocation graph. In this case, there are only one resource instance. There are only one resource instance. What happened about one resource basically? What happened about the instances? Let's say R3. Okay, so let's make again the diagram. Let's R1 resource, R2 having two resource instance, R3 is also having two resource instance, and R4 is having three resource instance. And we have a process P1, P2, P3, and P4. Now, when we have multiple resource instance and how the representation is going to look like, similar way that we do in the above diagram, we have to do the same thing. So let's say that R3 is assigned to P1, so the edge comes from R3 to P1. Similar way, if R1 is also assigned to P1 in above diagram, you can see that R1 and R3 is assigned allocated to basically P1, allocated to P1. So in this way, you can represent R3 and R1 allocated to P1. Okay. Okay. So now the other resource instance assigned to P2 because P2 want R3 instance, uh, R3 resource basically. In above diagram, there are only one R3 resource, but in this, there are two instance of R3 resource. So now P2 can able to get that R3 resource. Okay. So this is how you can represent the diagram. Okay, so I guess you understand about RAG, that what is basically resource allocation graph, and in similar way you can easily make the resource allocation graph. Now we are moving towards the next part, which is necessary condition for the deadlock, because we are going to understand about the deadlock, that we understand that okay, this is how the diagram is going to look like, but what is the use of this diagram? So these diagrams are basically used to detect the deadlock in a system, in a program basically. Okay, so for that we need to understand about the condition, that what are the conditions which is necessary for the occurring of a deadlock. So necessary condition, necessary condition. Okay, so the first one is called mutual exclusion. mutual exclusion. Okay. Second one is hold and wait. Hold and wait. Third one is called no preemption. No preemption. And the fourth one is called circular wait. Circular wait. Okay. So now understand these things in detail, that what is basically hold and wait, mutual exclusion, no preemption, and circular wait. So first of all, we understand about the mutual exclusion. So what is a mutual exclusion? Basically, it says that at a time, one resource is allocated by only one process. One process can have at most one resource at a time. Okay. So this is what a mutual exclusion. Mutual exclusion. What did it say? It says that at a time, one resource is used by only one process. One at a time, one resource is used by only one process. Means you cannot assign a single process to so many resources. Means in this case, you can see that R3 is assigned to P2, R4 is also assigned to P2. So this is what the mutual exclusion here, it's failed. Mutual exclusion says that at a time, one resource is allocated to one process. One resource is allocated to one process. Okay, so I hope you understand about the mutual exclusion. Now the second thing is called hold and wait. Hold and wait. Now what is hold and wait? It says that each deadlock process must hold at least one resource. Each deadlocked process must hold at least one resource and should wait for at least one resource. It hold one resource and wait for another resource for the occurrence of the deadlock. Okay, means uh, uh means let's say hold and wait. Okay, hold and wait. Let's say we have a P1 process which basically need hard disk. Hard disk. This is what basically P1 have. P1 hold hard disk, but P1 need printer. So P1 wait for the printer for the completion. P1 already have hard disk. When P1 get printer, it complete. It P1 process is completed and hard disk is free and printer is free then. But right now P1 is not completed because P1 is wait for the printer. P1 is wait for the printer. And let's say we have a P2 process which basically use printer and wait for keyboard instruction. So here you can see that printer is have P2 is having printer and wait for some other resource for the completion. When P2 is completed, then printer is getting free and that printer is used by the P1 process. Okay. So here you can see that how the loop is going to make. And let's say that we have P3 process which is using keyboard, which basically having a keyboard, and he is waiting for hard disk, waiting for hard disk. So here you can see that this is what the meaning of a hold and wait means. For a deadlock, for each deadlock process must hold at least one resource and should wait. Process must hold one resource and should wait for at least one resource. If this condition happen, then we can say that a process is going under a deadlock. Okay, because P1 is not completed if P1 not getting a printer, and P2 is not completed if they don't get keyboard. P3 is not completed if they not get hard disk, and hard disk is not released by P1 because it's hold by P1. It's not released until the print he have a printer. Similar case with P2, similar P3. So it goes in a loop and a loop. Hey, hold and wait for one process. processes hold one resource and wait for other processes, other resource basically. So then we can say that this is what a hold and wait condition. If this condition arrives in a process, then we can say that the process goes into deadlock. Okay. So what it is, each deadlock process must hold at least one resource and should wait for at least one resource. If this condition is true, then we can say that deadlock is occurring. Okay. Now, the third one is called no preemption. No preemption. Now, what is the meaning of this? It says that a resource which is allocated to a process cannot be preempted. Means you cannot, operating system basically cannot forcefully take the uh, operating system cannot forcefully take the hold process for a from a process basically cannot take the hold resource from a process. This is what the no preemption says, that if it does, then it means, let's say operating system take hard disk resource from P1. If it take, then it means P3 can easily get hard disk because hard disk is now free. So P3 can get that resource and P3 is completed. If P3 is completed, keyboard free. Keyboard is goes. P2 can use keyboard now. Then P2 is also free. So now there is no deadlock. But we need a deadlock. What are the necessary conditions? Necessary condition is should not preemption. There should not be a preemption. Means a resource which is allocated to a process, should always be with the process. Operating system cannot preempt that process. Okay, this is what the meaning of a no preemption. Okay, so a resource which is allocated, to a process can not be preempted. Cannot be preempted. This is what a no preemption is. Okay. Now the last fourth one, which is circular wait. Circular wait. Now what is a circular wait? Circular wait says that each deadlock process must wait for each other in a circular manner. Let's see this example again. P1 is holding basically hard disk resource waiting for a printer. P2 is having printer waiting for a keyboard. P3 having keyboard and waiting for a hard disk. So here you can see that loop is going to occur. Hard disk P3 cannot get hard disk because hard disk is assigned to allocated to P1. P1 is not going to leave this hard disk. So if P1 not leave, then P3 is not completed. If P3 is not completed, keyboard is not free, means P2 is also not completed. If P2 is not completed, printer is not getting free, means P1 is also not completed. So the cycle here you can see that it's a circular loop. This is what called a circular wait. Okay, this is what called circular wait. So each deadlock process must wait for each other in a circular manner. Then we can say that deadlock is occur if these are the four conditions basically for the occurrence of a deadlock. If these four conditions are true, if any one of these four conditions are true, any one, mutual exclusion, if at a time one resource is used by more than one process, then we can say that deadlock is occur. If hold and wait, this scenario is going occur, means one resource is hold and one resource the process need that particular resource, but that resource is assigned to another process. Then we can say that hold and wait will occur. means deadlock is occur. If operating system forcefully not scratching the resource from a processes, then we can say that operate that deadlock is occur, because that resource is always be that process never leave that resource, and if it not leave that resource, other process is also not getting completed, means no preemption, means deadlock is occur. And the last was circular wait, means if it is in a loop, then we can say that deadlock is occur. If we true any one of these four conditions, then we can say that deadlock is occur any one of these four conditions. Okay, so these are the necessary condition for the occurrence of deadlock. So I hope you understand these things. And this video, these are we are understanding about the deadlock and the necessary condition. This is all about that. In the next video, we understand about the recovery from a deadlock. If deadlock occurs, then what are the methods to recover from a deadlock? Okay. So in this video, this is all about. Thank you for watching this video. Like the video and subscribe my channel.